You know, right now, thousands of miles above your head, there's this massive, invisible traffic jam happening. And it's getting serious. According to a new report from ISRO, India's space agency, we're actually reaching a crisis point. So let's break down what's going on with this growing problem of orbital congestion.
So how big of a problem are we talking about? Well, get ready for this number, 150,000. That's right, 1.5 lakh. This comes straight from ISRO's latest report for 2025. And that's how many collision alerts just India's satellites got in a single year. Think about that for a second. That's hundreds of warnings every single day about a potential catastrophic impact up in space.
But here's the real question, right? What does it actually take to avoid just one of these potential collisions? I mean, every single one of those alerts, that's not just a blip on a screen. It's a potential disaster waiting to happen. So really, how do you dodge a bullet that's screaming along at over 17,000 miles per hour? The answer? Well, it shows you just how incredibly high the stakes are now. Okay, so that huge number of alerts, it's not just a random stat. It's really a symptom of a much, much bigger problem. The best way to think about it is like a cosmic traffic jam, a massive one with no stop signs, no traffic lights, and where everybody's flooring it at thousands of miles an hour. So where is this traffic jam the worst? Well, the data, which is mostly tracked by the U.S. Space Command, it all points to one specific neighborhood, low Earth orbit, or LEO for short. You can think of LEO as the busiest highway right above our heads. It's just the most convenient and cost-effective place to put all the stuff we rely on. You know, internet constellations, Earth observation satellites, the whole shebang. And as you can imagine, that whole area is just getting dangerously, dangerously crowded. All right, so how on earth did we get here? Well, it's all down to what you could call the great satellite boom. Seriously, we're launching things into orbit at a rate that's just completely unprecedented. And it's changing the entire environment up there, for good. And this chart from the ISRO report, it really lays it all out, plain and simple. Take a look. In just 1 year, we launched 4,651 new objects into orbit. Okay, but how many came back down and burned up? Only 1,911. The math here is, well, it's not great. We are adding to our orbit way, way faster than it's clearing itself out. And if you thought that was bad, here's the real kicker from the report. ISRO is warning that with this absolute explosion of giant satellite constellations, we're on track for the number of active, working satellites to actually outnumber all the existing space junk. And that could happen within this decade. To put it another way, we are very quickly becoming our own biggest threat in space. So, with all this chaos up there, how do we protect these incredibly expensive, billion-dollar assets? This isn't something you can just ignore and hope for the best. Nope. Space agencies are in a constant state of alert, actively taking steps every single day to dodge these orbital bullets. And that brings us to this number, 18. In 2025 alone, ISRO had to perform 18 of these critical dodges. They're officially called collision avoidance maneuvers, or CAMs for short. That means 18 separate times they had to make the call, fire up an engine, and physically move a satellite to get it out of harm's way. And trust me, pulling off one of these maneuvers is an unbelievably high-stakes, super stressful process. It all starts with that initial alert. From that moment, teams on the ground are in a race against time. First, they have to analyze the risk. Is this a real threat or just a false alarm? If it is real, they've got to quickly plot a new course. But then, and this is key, they have to check that new path to make absolutely sure the dodge doesn't just put them in the path of something else. It's only after all those checks are green that they can finally give the command to fire the thrusters. So where is all this dodging and weaving happening? This table tells the story perfectly. You can see right here that 14 out of those 18 maneuvers, yep, the vast majority, were for satellites in that super crowded low Earth orbit we were just talking about. That's it. That's the epicenter of the whole problem. And this is what's so wild. The solution itself is full of risk. Get this. In 2025, ISRO had to change its plans for orbital maneuvers more than 80 times just for its LEO satellites. Why? To make sure that while they were solving one problem, they weren't accidentally creating a brand new one. It's exactly like swerving to miss a car on the highway, but you have to be careful you don't swerve right into another one. Okay, so this constant daily dance of detection and dodging, it just can't go on forever. It's not sustainable. So that begs the question, what are the long-term implications here? And what could the future of managing our skies even look like? Well, pretty much all the experts agree on one thing. We need something like a coordinated space traffic management system. The easiest way to think about it is air traffic control, but for space. A single global system that can track everything, coordinate all the movements, and basically deconflict the thousands of objects whipping around our planet. It's the only way to keep our vital space infrastructure safe. And that, of course, leaves us with one final, absolutely massive question. Look, building a system like this is a monumental technical challenge, no doubt. But the geopolitical challenge? That might be even bigger. As thousands and thousands of new satellites go up every single year, who gets to write the rules of the road? And who, ultimately, gets to be the traffic controller for space?